The journey of air, from womb to the stars in the womb, the pre-breath experience. It's strange to think that before we even take our first breath, we're surrounded by a fluid-filled world. Inside the womb, the fetus receives oxygen from the mother's bloodstream through the placenta. No lungs are needed yet. Here, our oxygen doesn't come from air, it flows directly into our blood, providing life even before our first cry. The moment we're born, first breath. The moment we are born is magical. We take our first breath of air as we transition from a fluid world to one filled with oxygen, nitrogen, and other gases. This is our first introduction to Earth's atmosphere, a mix of gases we'll grow familiar with as we live and grow. Earth's surface, the air we breathe every day. At the Earth's surface, we breathe in the familiar mix of 78% nitrogen, 21% oxygen, and 1% other gases, including carbon dioxide and argon. Every breath we take brings life to our cells, fuels our energy, and sustains us. But as we move to different environments, the composition of this air can change dramatically. Deep underwater, the gases divers use underwater air behaves differently as the pressure increases. For shallow depths, divers use compressed air, but as they go deeper, special gas mixes are needed to avoid health risks like nitrogen narcosis or oxygen toxicity. Shallow diving, 0 to 40 meters. In shallow dives, compressed air is the go-to system. Divers use a standard oxygen tank filled with air, and the exhaled bubbles escape into the water. Nitrox diving, 0 to 40 meters. For extended dive times, nitrox is used. It's a gas mix with higher oxygen levels, which helps divers stay under longer, without absorbing as much nitrogen. Trimix diving, 60 to 100 meters. For dives between 60 and 100 meters, divers use a gas mix called trimix, which includes oxygen, nitrogen, and helium. The helium helps reduce the risks of nitrogen narcosis and oxygen toxicity at these deeper levels. Heliox diving, 100 to 300 meters. In commercial or technical dives that go beyond 100 meters, heliox, a mix of helium and oxygen, is used. This allows divers to work in very deep waters, where even trimix would be unsafe. Saturation diving, beyond 300 meters. For extreme depths, saturation diving allows divers to live in pressurized environments for extended periods, breathing a mix of gases like heliox to survive and work in the ocean's depths. Caves, trapped air beneath the earth. Caves can contain air that feels different, sometimes heavy or even toxic. Air trapped underground can have a higher concentration of carbon dioxide, making breathing more difficult. In some extreme cases, pockets of poisonous gases like methane or sulfur can make caves dangerous. Here, air becomes a variable we have to respect or risk our lives. Mount Everest, the thinnest air on Earth. As we move higher above the Earth's surface, the air thins out. At the top of Mount Everest, oxygen levels are only about 1/3 of what they are at sea level. This is why climbers need oxygen tanks to survive. The thin air up here makes each breath feel like a struggle, but for those who reach the summit, it's a breathtaking reminder of just how dependent we are on our atmosphere. Outer space, the void beyond Earth, and then there's space, a place with no air at all. In the vacuum of space, there's no oxygen, no nitrogen, no atmosphere to carry sound or sustain life. Astronauts rely on spacesuits and life support systems that simulate the Earth's atmosphere to breathe. Without them, we wouldn't survive even a few moments. Space reminds us just how precious our planet's atmosphere really is. The fragility of air, from the protective womb, through the diverse environments of our planet, and into the vast nothingness of space, air is one of the most fundamental aspects of life. Each environment brings unique challenges, but one thing remains constant: our reliance on that perfect balance of gases that make up the air we breathe. Cherish it. Cherish it. Without it, life as we know it simply wouldn't exist.